Next speaker will be Amber Dukes from the University of New Mexico. She'll be speaking about the intersection of what we eat and depression and inflammation. Take it away.
Is it on? Can you hear me? Yes? Okay. Good morning, my name is... No?
No.
Can you hear me now?
Yes.
Perfect. Good morning. I'm Amber Dukes. I have a master's in evolutionary psychology from Brunel University in London, and I'm currently working on a Ph.D. in health psychology and a master's in public health at the University of New Mexico. So today I'll be talking about diet, inflammation, and depression. We'll start with a little roadmap. So I'll give a brief introduction to depression, and then also inflammation as well as the gut. So I'm not attempting to explain all cases of depression today. I believe that this applies to a subset of people potentially. And I also won't be talking about neurotransmitters. So this will be the only time that you hear me say the word dopamine. I'm instead talking about a different pathway that we don't typically consider when talking about depression. I'll talk a little bit about food, of course, a little bit about mismatches in the modern diet, as well as something most people don't consider, that we do have adaptive responses to the foods that we consume. I'll touch on the modern gut and why that's particularly problematic when combined with the foods that we're eating today. Because I have a background in evolutionary psychology, I'll talk about the ultimate explanation in addition to the proximate explanations for this behavior. And then, of course, I'll wrap up with a conclusion. So to start, depression has been projected to be the second leading cause of disability by the year 2020. It's extremely costly. In 2003, which is the most recently updated figure I could find, it cost $83 billion in the US alone. This is due to lost productivity and health expenses. It comes with an increased risk of suicide, substance abuse, and it's very, very common. We see it in 50% of children and adults, or 50% of children and adolescents, 20% of adults, and 10% of adults are currently on antidepressant medication in the United States. It's on the rise in Western nations, and it's starting to co-occur with some of the other diseases of civilization. So it's particularly problematic because it is currently on the rise. So there are, of course, many different things that contribute to depression. You know, our Facebook addiction could absolutely be contributing to it, and I think it does. I'll just be talking about one potential contributing factor of the modern lifestyle. So inflammation is that contributing factor that I'll be speaking about, or that I am speaking about. So inflammation typically signals injury or infection within the body, right? So you get a splinter, the area gets inflamed, right? You've like broken the envelope of your body, and you have something that your immune system needs to fight off. Also, if you're infected by a pathogen, some kind of parasite or bacteria or virus, your body's going to respond to that. So that's the typical, like the evolved domain in which we normally see this. We usually get an immune response in when there are cues of pathogens, so pathogen-associated molecular patterns. One of these being lipopolysaccharide. I'll abbreviate it LPS for the rest of the talk. It's particularly important. It's a component of the cell wall of gram-negative bacteria. Okay, so it's really common bacteria that we have in and out of our bodies, but this is one of the ways in which the immune system recognizes that we have an infection. So when we see injury or infection within the body, we get a release of inflammatory cytokines. So these include the interleukins, which I'll abbreviate IL. Interleukins 1 beta, 2, 6. These are all implicated in sickness behavior and depression. We also see there's an anti-inflammatory cytokine called IL-10, which is also important. And we also see things such as tumor necrosis factor alpha, which I'll abbreviate TNF alpha, the symbol, and then C-reactive protein as well. And there's also others, but I won't go too deeply into it. So most of the diseases of civilization are inflammatory disorders, type 2 diabetes, rheumatoid arthritis, obesity. You guys know, it's like a long list. So inflammation is associated with depression. There's both correlational evidence and causal evidence for this association. So we see increased immune disorders in persons with depression. as well as like increased levels of inflammatory cytokines. One of the inflammatory cytokines can be up to 170% higher in persons with depression who have no other immune activation. We also see depression as cytokine therapy. So for persons who are being treated intentionally with like interferon, it's a pro-inflammatory cytokine. They use this for things like chronic hepatitis. These persons, many of them do develop depression. Not all persons treated with cytokine therapy will develop depression. There are particular factors that predispose persons to developing major depressive disorder as a result of being on cytokine therapy. So, we're talking about food, so we'll talk about the gut. The gut is particularly important to my argument. So, the gut has this really interesting job of that we don't normally think of. We kind of take the gut for granted. So, it has to recognize both self-tissues and not fight against those, as well as recognizing harmless food proteins and then pathogens that might come in on those foods. So, it's got to differentiate between all of these things. It has three main recognized types of residents within the gut. The first of these are the commensals. So usually when we think of gut flora or when you're talking about the gut microbiome, most people think particularly about our commensal organisms. So we have about 100 trillion of them at any given time. They far outnumber you. So they have a very important role in maintaining your bodily health. They're implicated in motility, so intestinal motility, nutrient absorption, metabolism, immunoregulation, so they can actually secrete their own IL-10, which is the anti-inflammatory one. So they actually, do a lot of the work for the immune system. You have to have a normal gut flora balance is really important in brain development as well. We're starting to see links between anxiety and particular gut flora populations. You can take certain probiotic strains to decrease anxiety, at least in rats. Rats can get away with it. There's work being done in humans currently. So we also have what's called the brain-gut enteric microbiota axis, which is comprised of the central nervous system, the neuroendocrine and neuroimmune systems, the sympathetic and parasympathetic autonomic nervous system, the enteric nervous system, which is like the brain and the gut, and then the intestinal microbiota. There's bidirectional communication between these. So the brain can tell the gut what to do, and the gut can tell the brain what to do. So some of this is like doing things that change the mucus secretion in the gut itself in order to alter the flora, change the motility, which can, give you different feelings. So we also have the pseudocommensals. So the pseudocommensals are tolerated in the gut. Most of them pass through pretty quickly. I'll talk about those a little more later. We also have pathogens in the gut. Some of them just reside there all the time. And we also have the problem with pathogens that are introduced into the gut through the food that we eat, through the environment that we're in, and those can cause immune activation. There is also evidence of a link between the gut, the condition of the gut, and depression. So Michael Mays, if you read the Evolutionary Psychiatry blog, he's been talked about quite a bit on there. He's found a link between increased leakage, so leaky gut, and the leakage of lipopolysaccharide, which is the cell wall component, into the bodies of persons with depression. These people have higher serum antibodies against LPS than non-depressed persons. Okay, so I'm going to talk a bit about some mismatched foods in the modern diet. There's a lot that get talked about at conferences such as these. I'm going to focus on just 3 components that I find to be problematic in my research. So lectins are the first one. So lectins we find in grains and legumes. They are plant defense proteins. So the plants evolved to have these in order to slow the consumption of the plants by the animals eating them. So they do this by binding carbohydrates, which means they bind the natural sugars in your body. So they can actually cause leaky gut by causing junctions between the cells, so they actually cause things to kind of spread out. They also lead to an overgrowth in E. coli in the gut, so a combination of leaky gut and more E. coli leaking into your system will lead you to some immune activation. They can also lead to, there's a study that shows or suggests that they can actually lead to the release of the pro-inflammatory cytokine interleukin-2. So on their own, they cause immune activation. They lead to other things that cause immune activation. Part of the problem is the processing of foods. So, we're part of like a convenience food revolution that's been going on for several decades now. Not a lot of people properly soak their beans, cook them for long periods of time, use a fermentation process, so that makes these lectins particularly problematic. I believe that they could be tolerated by some people who don't have underlying, autoimmune disorders if they're properly processed. So, which they're not in most cases. Another problem is the combination of high carbohydrates and high fat, so the typical fast food meal leads to postprandial dysmetabolism. So it can actually lead to endothelial dysfunction and just general inflammation of the body when you're getting this combination of really high carb and really high fat. Some of that has to do with the particular types of fats, so I'll go into that more later. I touched on the lack of traditional preparation. So another issue is just the dense acellular carbohydrates. So what this means is that when you grind something to flour, you're breaking down the cell wall of the plant. You're actually changing the way things are metabolized in the gut. There's a great paper by Ian Spreadbury from 2012 where he talks about this concept. He suggests that it leads to an inflammatory gut microbiota, and that certain people whose ancestors in the more recent years have been eating these for more generations can get away with eating some, whereas other people have a little more trouble with it. The other issue is the lack of anti-inflammatories in the standard American diet. So plant flavonoids are anti-inflammatory in and of themselves in a lot of cases, micronutrients as well in some cases. If you've been to several of the talks this weekend, you know that plants don't contain the same good stuff that they used to contain because the soil is depleted. So even if people are getting fruits and vegetables, it's not the same as getting fruits and vegetables 200 years ago. There's evidence that shows that putting people on an intervention with higher plant and vegetable consumption can actually reduce inflammation. Some of this is just due to displacing other foods in the diet, right? Like if you're eating more fruits and veggies, you're eating fewer French fries. But there is also evidence that plant flavonoids in and of themselves can lead to a reduction in inflammation. Lack of spices in the standard American diet. Most American households, you see like maybe some dried parsley and some salt and pepper. Spices are, yes, you guys agree, I can tell. Okay, so, we learned on day one from Dr. Saad that some work by Sherman and his crew that spices are antimicrobial. So we tend to see them in environments where there are there's more chance of being infected by pathogens in the foods that you eat. So spices downregulate inflammation by being antimicrobial. The ones that are higher in magnesium are better at reducing inflammation, but we don't see a lot of that in the American diet. And also the lack of fermented foods. So fermenting food can actually break down some of the lectins. It can make food more digestible. And also when you're eating fermented foods, you're introducing more commensals into the gut, which can both outcompete pathogens in the gut for residence in your gut, as well as directly secreting things like IL-10, which are anti-inflammatory. So the adaptive response to foods. Joe Alcock from the University of New Mexico released a paper with his colleagues in 2012 called Nutrient Signaling, Evolutionary Origins of the Immune Modulating Effects of Dietary Fats. So many of us in here know that some fats are inflammatory and some are anti-inflammatory. If you looked at the reason behind this. So some free fatty acids, which is what happens when fat breaks down in your body. Some of them, such as many saturated fats, but not all of them by any means, actually provide fuel for gram-negative bacteria, so those ones that I talked about in the beginning. It can actually help to strengthen their cell walls, and they can use it for fuel. The antimicrobial free fatty acids, which are the anti-inflammatory ones, actually they can put pores into the cell walls of gram-negative bacteria and actually fight against them. It can prevent them from binding to the walls of the intestines, so they actually fight bacteria, right? And we see these in like breast milk. You have them on your skin. Thank you. So what he suggested is that that this works for fats, I'm collaborating with them currently to work on a paper looking at sugar. So there's evidence from like a paper in 1969 that shows that glucose is protective to bacteria. It's not only just fuel for them, it's more protective than sucrose or peptone. And we also know that we have prebiotic oligosaccharides, such as what's found in breast milk. So breast milk contains both protective free fatty acids and protective prebiotics. So here's basically how it works. So when you consume fat, your body can use the type of fat to cue what's going to happen next in the gut. So if you consume a fat that's is pro-inflammatory, the body can make the guess that because this fat generally leads to protecting bacteria in the gut, we should upregulate, so we should increase inflammation in order to fight off this potential infection. If it's something that would usually be antimicrobial, so it would destroy bacteria in the gut, then the body can compensate by downregulating, so decreasing inflammation, which is energetically saving, right? So if we can downregulate our inflammation, we're good. So I assume that this probably also happens with sugars. This is why we see like a decrease in inflammation that comes along with fiber. Commensal bacteria can use fiber in order to create fuel, but it's harder for pathogenic bacteria to do this. So some of what we see in terms of the bidirectional communication between the gut and the brain and the rest of the immune system is signaling through both pro-inflammatory cytokines as well as short-chain fatty acids. So commensal bacteria break down fiber into short-chain fatty acids, so it can tell us something about the population that's in the gut based on how many short-chain fatty acids are being produced in the gut. So we would expect to see an inflammatory response to fats that we evolved with. Like, these have been around for a very long time. We just happen to be eating more of them than usual these days, which is why we see an increase in inflammation in the standard American diet. So some of these that are pro-inflammatory would be trans fats and the long-chain saturated fats. We see anti-inflammatory actions with the short and medium-chain saturated fats, so coconut oil, as well as unsaturated fats. The PUFAs tend to be more anti-inflammatory than the MUFAs. But of course, omega-6 is weird in there, right, because it's pro-inflammatory. So we see it particularly with omega-3. The old friends hypothesis, if you saw Chris Kresser's talk yesterday, you know that our immune systems are not as well trained as they had evolved to be, so they tend to be overactive because we're not exposed to things that would downregulate the activity of the immune system, which leads to an overactive immune response, which means that our guts are more likely to react to typically harmless food proteins, like lectins such as wheat germ agglutinin, so things that are in wheat. It also leads us to attack our own self-tissues, as well as typically harmless environmental irritants, which is why we see an increase in asthma. So this increase in inflammation can lead to an increase in depression. And they've got a paper that came out in 2010, Inflammation, Sanitation, and Consternation, where they talk about the link between the old friends hypothesis and depression in modern life. So the proximate explanation for this is the how part, is that inflammation, we have our interleukins and our other pro-inflammatory cytokines, which lead to sickness behavior. You're inflamed, and thus your brain is getting cues that you're sick, which means you should conserve your energy so you can heal. Being sick, the sickness behaviors that come along with sickness aren't just annoying, they're actually adaptive because it gives you an opportunity to sleep more so your immune system can work harder. Evidence, as I mentioned a little bit before, it's elevated chronic illness. We see depression and cytokine treatment in a lot of people, about a third of people. Higher interleukin-1 beta in depressed persons, and depression in lipopolysaccharide. You can give people lipopolysaccharide, many of them will become depressed if you inject it. So the ultimate explanation, why does this happen? There's a lot of similarities between sickness behavior and the diagnostic criteria for major depressive disorder. You can see them listed out here. They get, you do get just changes in sleep patterns. It could be more or less depending on if they have atypical or melancholic depression. So why does this happen? Depression was co-opted from sickness behavior. So sickness behavior existed first, but it served a really good function in terms of depression. So with depression, it often occurs when you are going for a goal and you're unable to meet it. So you should disengage from that. Being fatigued in the face of like unattainable goals is a really good thing because it allows you to conserve your energy in order to reprioritize what it is that you're doing. There's some evidence that suggests that persons who repeatedly continue to try to reach an unattainable goal have higher inflammation than those who give up. So it allows you to reevaluate, seek new solutions, get help through social support, through the same things that we see in sickness behavior. So the implications are, I think, some people may be sick rather than depressed. Not everyone. I think that some people actually are like trying to attain goals that they can't, so they're becoming depressed because of that. They will also have higher inflammation. But I think that some people are eating foods that are making them sick. And because there's so much similarity between sickness behavior and depression, they're going to the doctor and they're being diagnosed as depressed and perhaps being put on antidepressants. When it might be useful for at least some people to reevaluate what it is that they're eating, take care of their gut, help them heal the gut, and then see some of this depression resolve. So traditional diets do appear to be better for mental health, the traditional preparation, the lack of potential allergens. Over-the-counter anti-inflammatory drugs are not the answer. They can actually cause disruptions to gut flora. And although they may be decreasing inflammation in the short term, they're not resolving the issues in the gut. So you will probably still get some sickness behavior, I think, based on the fact that there's still some dysbiosis going on. We do need intervention studies in the future, looking at changes in diet and then changes in depression and inflammation, as well as diet and then changes in gut flora. And further reading if you are interested. Thanks.
Thank you, Amber. We are just about out of time, but I'm sure there's a ton of questions, so maybe let's get one quick question if anybody has a micro question out there.
Could you define traditional diet that would improve mental health?
A traditional, yeah, so when I say traditional diets, I mean like let's leave out the processed foods from the standard American diet, don't eat Twinkies. If you're going to eat foods that are not typically considered to be paleo, process them in a traditional manner. So soak, sprout, cook for long periods of time. Of course, only if you don't have like an underlying autoimmune disorder. So eat things that are not full of trans fats and other pro-inflammatory issues.
Thank you, Amber. You can also ask your questions in the break here. The next talk will start in about 5 minutes.